Hello again, everyone, and welcome to the new gridSession. The session today is actually a joint webinar hosted by three organizations, gridX, GEO, and Delta EE. Our topic today is about the European home and energy management markets. We're going to talk about the current development of HEMS and also the lessons learned from different markets. Please feel free to write your questions to us using the text box under the live stream, and we will try to cover and answer the questions at the end of the webinar. Haven't yet introduced myself, I'm Zoshan, moderator today from Delta EE, and I'm joined by three great panelists, and you can see their faces on the screen. I'll start with my colleague Alex and let her introduce herself. Hi, Alex.
Hi, Sushang.
The next one will be Tom from GEO, who is joining from the UK. Hi, Tom.
Hi, Sushang. Thanks for having me here.
Yeah. And finally, we have Theo from gridX, who is based in Germany. Hello, Theo.
Hi, everyone. Happy to welcome you to our international grid session today.
Thanks, everyone. So our agenda today is going to spend around 40 minutes to cover the Delta EE definition and framework of HEMS. We will then take a deeper dive into the two most important European HEMS market, Germany and the UK. And finally, we will have a free discussion on some hot topics in the HEMS market. So we will move to the first section, and I'll hand over to you, Alex.
Thanks, Sushang. I would like to start with maybe a short introduction to Delta Energy and Environment, which is a research and consulting company focusing on the energy transition with a strong emphasis on behind-the-meter technology. So we have been following this market for more than a decade now, and our expertise cover key aspects and key technology of the energy transition. So namely, as you can see on that slide, e-mobility, new heat, decentralized generation, and many other topics. So Delta Energy Environment is based in the UK, and our focus is mainly on Europe, where the majority of our clients are based. We work with a wide range of energy players, such as utilities, startups, governments, and many more. As you can see on the next slides, we currently have 15 different research areas, and the most recent one that we have launched are focusing on hydrogen and distribution networks. But the research that we will be presenting today was done by our New Energy Business Model Service and our Connected Home Service. So maybe let's jump straight away in definitions. So home energy management, or HEM, has been a very large research topic at Delta EE for many years now. And as the trend is capturing more and more interest, we've seen differences in how the industry uses the term HEM or HEMS. So at Delta Energy and Environment, we define home energy management as a system which autonomously monitors, controls, and optimizes the timing, volume, and mix of energy flows within the home. And this is in order to minimize customers' energy cost while meeting their preferences. And by preferences, we mean comfort, electric vehicle availability, carbon emissions, and many more. So more specifically, as you can see on the diagram on the right of the slide, the home energy management system optimizes the energy used by the main electricity loads of the home. And these loads can be only consuming energy, such as a heat pump or direct electric heating, and others also have the ability to store energy. So this is the case of a battery or an electric vehicle. Finally, we have the intelligence of the HEM system, the brain that will autonomously control the different loads to optimize energy flows. And this intelligence can be integrated in an appliance, which we see increasingly, in a dedicated gateway, or it can be located in the cloud. The optimization is typically done based on a variety of parameters. It can be very sophisticated and include user behavior analysis, forecast, or it can be rather simple. home energy management proposition can focus solely on what we call home values. So that's the blue area on the slides, which means that they would offer one or several of the following use cases: self-consumption optimization, time of use optimization, or capacity charge management. But the thing is that home energy management can also bring significant benefits to the wider energy system. And by energy system, I mean the energy grids and energy markets. So HEM providers or their partners can use residential loads to optimize their position on wholesale markets or to participate in flexibility markets. And this is what we call the electricity system use cases.
Yeah. Hi, Alex. Sorry for chipping in, but it's just very interesting that you mentioned that the home energy management can even interact with the wider electricity system. But presumably, there are a lot of companies starting their solutions from the home level. Are there many solutions or companies today playing around the use cases or value streams in the electricity system, actually?
That's a very good question. Actually, what we're seeing at the moment is that there are very few commercial applications because the return on investment for such solutions at the moment is quite long. But we see a lot of pilot projects, and we also see residential demand-side response markets opening across Europe, which is quite promising for that type of use cases. Finally, before we move on, I'd just like to mention as well that HEM can be used to optimize energy flows at the local community level once the optimization at the house level is done. That's our framework. So as the market develops, we're seeing a lot of different propositions being launched, and those address different use cases, different assets. And this is why at Delta EE, we've developed a framework enabling to classify them using two criteria. So the first one, the vertical axis, the number of assets that is covered by the solution. And the second one would be the number of use cases covered on the horizontal axis. So when I'm talking about use cases, I'm referring to the ones that I cited on the previous slide. So we end up with that framework, and on the bottom part, we're going to have what we call appliance optimization, where we have a single asset being optimized. For instance, a charge point being optimized for time of use. And the top part is actually going to be home energy management, where we're going to have multiple assets being managed together. So when we move to the right part of the graph, we have several values being captured together. And this increases significantly the complexity of a HEMS system. This is therefore for us the most important indicator of advancement.
Yeah, it's really interesting. It looks like every propositions in the market is moving towards advanced HEM. Is that the final or ultimate destination of every solutions today, Alex?
It could, because this is what offers access to most value streams. But at the moment, I would say that interoperability, technical complexity, and lack of value streams remain big hurdles to the development of advanced HEM systems. So I'd say that right now, a lot of players have pilot advanced systems, or they're offering some, but most of the commercial activity at the moment, in terms of sales, is happening with a simpler system. So briefly, before we move on to deeper dive into solutions, this is our map of Europe in terms of attractiveness. So we forecast that around 10 million of homes will be equipped either with appliance optimization or home energy management by 2030. And this is clearly pushed by the increasing uptake of heat pumps, of EVs, and large electrical loads. Something to note as well is that the HEM markets are very country dependent. Value streams openness, uptake of loads, and local market characteristics are going to push for HEM adoptions. So currently, what we're seeing is that Germany and the UK are clearly leading the way, and we expect this trend to remain the same in the next 5 years. This is due to local customer awareness, large install base of loads, high electricity prices, openness of flexibility markets, and many more aspects. So a consequence of that is that we're seeing a lot of innovation and companies operating in these markets. So very good examples of those are Geo and gridX. And I will actually leave the floor to them for a deeper dive in these markets and in their solutions.
Okay, thanks, Alex. Before we move to the next section, I just want to give you a very quick reminder that you can send us your questions under the live stream, and we will try to answer the questions at the end of the webinar. Now we will welcome Till to give us an introduction of gridX and the German market. Over to you, Till.
Yes, thank you very much for the general and the HEMS introduction. Hi again, everyone. My name is Till, and I also want to welcome to this international grid session. I work as a business development manager at gridX, and so I work with my colleagues on all topics regarding the expansion of gridX towards new countries, new use cases, new customer groups. And in the following, I'll present to you gridX and our HEMS activities in Germany and Europe. So let's get started. Firstly, let me start by introducing gridX in general to you. So we as gridX, we help enterprises launch digital energy products with our Xenon platform. Our platform as a service to maximize customer lifetime value, differentiate from competition, and master all the challenges of the energy transition. We are working on this since 2016, are working on our vision to connect all distributed energy resources to our unified platform, Xenon, our smart grid platform. We already have more than 10,000 devices connected and support devices of more than 30 OEMs. So we're trying to offer like a big interoperability. And we work in a B2B environment, as you can see below. We work together with leading companies from different industries on a broad range of use cases. And we are also active in different countries in Europe, for example, in the DACH region, in Benelux region, Italy, UK, Nordics, also doing first pilots in, for example, in Australia, also outside of Europe. When moving to the next slides, I want to introduce our platform in general to you. So as we see flexibility and the holistic energy management as main factors for our partners to be successful in a future energy system challenged by a lot of changes and challenged by competition coming from all different industries, our Xenon platform is built to unify all use cases from different domains on one smart grid platform and to really leverage all flexibilities that are in the market and that we can offer. So to provide full flexibility concerning the use cases and the specific regulation in each and every country, our platform is based in modules. Our platform is manufacturer agnostic, and we integrate devices across sectors. So from the electricity sector, but also from the heating sector, and of course, mobility sector towards EV charging. We also offer full flexibility in working with us. On the one side, you can choose from 15 pre-built modules to build your own energy product. On the other side, partners can use our gridX API to further develop their own solutions or existing products, focusing on their own logic without having to worry about the underlying infrastructure and implementation. So this approach, we call it the build with approach, adding this approach to the make versus buy decision, the classical decision. And we see this as a unique partnership model in the sector, customize and pushing our approach to sell customized solutions together with our partners. And there how we save partners thousands of developer hours and reduce their risk in developing costly solutions themselves. On the next slide, I want to explain how we build solutions with our partners. Also, for example, HEMS solutions, this is the topic for today. We leverage different values for our partners by adding a layer of connectivity and control to all distributed energy resources, producing, consuming, or storing energy. You can see them at the bottom. Doing this by connecting, monitoring, and managing all the DERs via our local edge device, our Gridbox, or through the cloud via APIs. And we do this for residentials, but also for C&I buildings, energy communities up to smart districts scaling up. In the cloud, we consolidate the data, of course, and also provide user interfaces, dashboards to monitor and control all the energy flows for partners, installers, and end customers. And there how we leverage values for all stakeholders. I will get into that in more detail later. Moving on, focusing now on the HEMS market, I want to start with our activities in Germany. So the underlying incentive currently in Germany are the phasing out feed-in tariffs to reach the climate goals. Of course, firstly, there are incentives needed to increase the renewable generation capacity. In Germany, for example, these were provided with different subsidies and feed-in tariffs, guaranteed feed-in tariffs, while other countries, for example, use net metering as a remuneration for PV generation. Now, in the graph, you see that the feed-in tariffs are decreasing strongly, while electricity prices are rising. So the gap is getting bigger and bigger. And this is a strong incentive and a growing incentive to maximize the self-consumption as the biggest underlying driver for HEMS systems in Europe, in Germany. And of course, we also see other regulatory incentives, but these are not that mature yet in the German market, also due to slow smart meter rollout in Germany compared to other European countries. So as we are building HEMS solution, on the next slide, I'm showing you the basis, connecting, monitoring, and visualizing assets. And so by providing digital interfaces for end customers, we foster a high engagement based on the transparency of energy flows. And again, there how we enable to strengthen customer relationships for partners with the end customers, with the prosumers. But there how we also improve upselling and cross-selling opportunities, and additionally provide dashboards for partners to do asset maintenance management for installers to also leverage remote maintenance potentials to save costs. So this is like the basis, the monitoring for the simple system. Then on top, of course, we do optimization of energy flows. So that's the core of our business, the energy management. We do so, for example, by providing forecast-based battery charging combined with optimized PV curtailment, PV surplus charging of EVs, or PV surplus usage for heating devices. And there how we can significantly increase the self-sufficiency of end customers and reduce costs and CO2 emissions. And additionally, we offer opportunities to differentiate from solutions, for example, from OEMs, like possibilities to prioritize the PV surplus or different charging modes for EVs that again foster the end customer participation and the end customer relationship. On the next slide, to give you a concrete example of a partner leveraging all these values with gridX HEMS solution, or being backed up by our gridX energy management systems, I want to introduce the Viessmann success story to you. Viessmann was originally coming from the HVAC sector, wanted to become a fully integrated energy solutions provider on the HEMS market. And they chose gridX as their partner, as their rollout partner, as our modular, flexible clean-on platform, our pace in developing solutions, and the unique way of working closely together in a long-term partnership gives them competitive advantages, and at the same time saves them developing time and developing costs and decrease the risks of own development. As you can see, looking at the KPIs, this really worked out. Viessmann is scaling the HEMS product in the German market and proceeding with a compound annual growth rate of 192%. And our manufacturer agnostic platform enables Viessmann as a basis to sell an integrated bundle of products. So not only heat pumps, but also PV systems, batteries, EV charging stations, and act really as an integrated end-to-end service provider for the HEMS solution. And very important for Viessmann are the digital end customer interfaces that we provide via dashboards and via mobile apps. They're how they can build long-lasting customer relationships, really maximize the customer lifetime value, and do cross and upselling of different solutions, devices, and products. And as validation, we brought a number. So the 50% with the Viessmann labeled mobile apps, we see that 50% of the users, of the registered users, log in daily, which is quite high for a market like the energy market, which used to be quite unattractive for everyone. But the end customers like the transparency and like to actively influence their own consumption, for example, with different charging modes for EVs, and therefore they really participate in the market, and we enable that. Also, we provide a multi-tenant architecture on our platform. So we provide also dashboards for installers and Viessmann itself. Viessmann can open up new revenue streams. For example, also, as I mentioned, by saving costs by doing remote maintenance. And of course, most importantly, the sufficiency optimization saves a lot of money for the end customers. We save about 80,000 euros monthly across all systems, of course, growing with the number of systems. And this is done by using more self-generated electricity from PV systems instead of feeding it into the grid. As I explained before, because of the gap in between feed-in tariffs and electricity prices in Germany, the value is rising and is quite strong already. And so looking beyond Germany, as I said, we're also active in other European countries. And again, partners benefit from our flexibility of our platform as a service and our flexible operation model to build customized solutions for these different markets. Because every country, as you know, has its very own regulatory framework, resulting in different incentives, different tariffs, etc. And also the maturity of decentralized energy resources, decentralized energy regeneration, and the maturity of the electrification of the mobility sector and the heating sector varies widely. So yeah, it's really necessary to adjust the HEMS solution to the different markets as use cases differ. For example, from self-sufficiency optimization to fuse protection to optimization based on capacity tariffs for residentials or time of use tariffs for residentials. And with Xenon, we are able to build these adjusted solutions easily because of our modular architecture. And that also enables us to be in the HEMS rollout preparation in 4 countries, plus piloting in other countries, in addition to the German rollout. Jumping back one slide, I will try to summarize the relevant use cases we provide in Europe, that we especially differentiate in the complexity of the use cases as well as the value. So looking at our partners concerning the value, of course, all use cases add value to the cumulative value of the HEMS product, but depending on a lot of factors, how big the value is for each use case compared to the complexity. And yeah, as I said, we're also targeting the complex use cases in different markets on a European level, possibly because of our flexible architecture. And yeah, for example, we're also doing pilots and rollout preparation towards aggregation for VPP as one of the more or most complex use cases. And there we also help partners to differentiate and take first mover advantage in the markets. From the end customer perspective, again, please jump one slide back. Perfect. Of course, the monetary value is the most important to start with. Here we show different setups of devices, different regulatory environments. We see savings of 15 to 50 euros to be made per month with our systems. Of course, this is just examples and it strongly depends on the setup, the energy prices, etc. But just to stress that we see a lot of values and big potentials with our in the HEMS area and with our modules. And moreover, to stress, of course, there are non-monetary values for the end customer as well. As I mentioned before, coming from the monitoring, the transparency, the participation, the ability to influence their very own energy flows, and also the interoperability of a integrated HEMS solution backed by gridX, being manufacturer independent and sector coupled. So coming to my last slide to conclude, we really see HEMS as a crucial part of the energy transition to increase renewable energy generation and automatically optimize the energy flows towards different incentives to match, on the one side, consumption with generation as a very important point in the energy market, and on the other side, to reduce the impact on the grid, which is quite costly and getting more costly at the moment. Challenges of HEMS providers are, of course, individual requirements of end customers, differing national regulations, but also the need to differentiate and be ahead of the competition, as the market is quite hard for being fought over from all different angles. And therefore, to create a successful HEMS product, from our point of view, corporates need great flexibility in building a HEMS solution, interoperability, and a strong customer relationship, for example, via digital interfaces. That's all from my side for now. Now I'm handing over to Tom, I guess. Go for it, Tom, and thanks for the attention.
Thank you, Till. Yeah, our next section will be Tom sharing with us about his learnings and experience from Geo in the UK market. Over to you, Tom.
Well, thank you both. And thanks everyone for joining. Pleasure to be here and share our learnings in this HEMS space. Quick introduction. So my name is Tom Whiffen. I'm a product manager here at Geo. We're an energy technology company in Cambridge based in the UK. And as you can see there, so we have a broad team, but PhD level, that are delivering energy feedback, control and automation. And then also we have this leading edge technology that houses all of our data science, artificial intelligence, cloud, firmware, UX, and the like. You'll see us pop up on various different events and white papers at different times. So thank you for having us today. If you click on one slide. We summarize that all under this vision. So we want to create a sustainable future where every household is able to reduce their energy cost and their carbon footprint without having to think about it. That all hangs on this premise that we believe people want to be sustainable, but they either don't know how to be, or it costs them too much when they find out, or whether that's financial or whether that's just an inconvenience. So the target is, how can we deliver savings without people having to think about it, and essentially hassle-free sustainability. So that's what we've been going after. If you click on one slide, how we do that to date has been largely around making energy visible. So this is our suite of energy displays, and they connect into the smart meters. So either in the UK through the SMET standard, or across Europe through the P1 ports. And you can see here, so on the left side is the Geo touch button and Geo accessible. And the accessible has voice control, not voice control, sorry. It speaks back to you and has tactile buttons, which is good for the visually impaired. But there's millions of these devices in the UK and across Europe. And that's helping people save 6 to 9% off their energy bills. But moving forwards, we're getting more and more into the connected space, and now have hundreds of thousands of connected devices out there in the middle. And then where you'll see how our conclusions from our study, which was called Core for Grid, resulted in us bringing together a lot of that HEMS technology, pardon me. Excuse me. A lot of the HEMS technology, we're moving from a Linux-based system in the home out into the cloud, and then using the energy display as the gateway for the whole home. So that's what we call the Trio Plus. And you can see it connects into all these different energy assets around the home. And then the squares on your right are the services that are enabled through the cloud. So the energy brain is what we call Core, and that's our home energy management system. If you click on one slide. So the big project we led was called Core for Grid. It was a groundbreaking home flexibility trial, part funded by the UK government, the Department of Business, Energy and Industrial Strategy, which is what BEIS stands for, and a whole bunch of industrial funding. So the partners there you can see on the right. The main aim of the project was to try and demonstrate that market and household acceptance and engagement in the future flexible grid was ready today. And particularly, we looked at 3 different areas. So was it technologically possible? Was it economically viable? And then was it socially acceptable? Do people actually want it at the end? So if you click on one slide about how we went about it. So these are the sites we had deployed up and down the UK. We deployed smart meters in every home. We wanted to use this as a rollout that's being incentivized by governments throughout the world. And so it's already providing that technological backbone for real-time energy data into the home. So we used those smart meters and then used our in-home displays to get real-time energy data without having to add any other metering. And then the energy retailer, EDF, that we worked with, they created a smart tariff called Go Electric, and that was a 2-tier tariff. So it had off-peak times of 8 pence per kilowatt hour and peak times of 16 to 18 pence per kilowatt hour. So we could use that to do the time of use optimization. Then we put 24 hybrid homes out there. And so the technology in each of the homes, we had our home energy management system. That was this Linux hub. Then we also gave them the Geo Home app. and connected up the different flexible assets that they had in their home. So all of the households had batteries, about a third had EV charging, an eighth of them, so 3 of the homes had heating control, and then 2/3 had solar generation as well. All of those we connected up to the HEMS system, to the smart meter, and then up to the aggregator platform as well. So Upside Energy, which is now Kraken Flex, part of the Octopus Group, they were providing the aggregator platform. And so then between Geo, ourselves, and Upside, we optimized for value across a whole host of different value streams. So principally, it was the self-consumption of the generation and also the smart tariff. But we also did a host of DSR flexibility revenues, so either leveraging the wholesale volatility through day-ahead and intraday markets, but also the distribution system operators and their sustain schedules. All of that we tracked longitudinally through the study. So we looked at the customer attitudes and the technical solutions and the financial and environmental KPIs. And so we can report back on progress now. So there you go. This is what we found out over the course of the study. We were able to deliver on that vision that we said at the beginning. Could we deliver cost and carbon savings without people having to think about it? Yes, we could. We put these batteries and these brains in people's homes, and that enabled them to save 49% off their electricity bill. And each of these trialists didn't have to do anything with their behavior. They could carry on living their normal life, and they didn't have to move their usage into the nighttime period because the brain and the battery was able to do that. We optimized for value, but we also got 14% carbon savings just because we were making better use of the solar and better use of the low carbon times on the grid intensity. And then when we surveyed the group of trialists, 74% of them would recommend it to their friends and family. Those that didn't recommend it, they were mainly wanting more control over the system, or they wanted, they felt that the upfront cost was too high for them for the return on investment that they would see. So just double clicking down on where those values come from. This is a little snapshot of 4 of the households that we had in the trial. So you can see some of them are in big detached properties. They have all the different assets connected, heat pumps, EV charging, batteries, everything you want in your future decarbonised home. Or you have the 1-bed flat in the bottom there, which has just a battery in the home with the smart meter. And so you can see how the values stack up and how their average daily energy demand varies. So the highest user, those that have moved all of their loads onto electricity, for them, the biggest value is in tariff optimization, because with the battery, they're able to move most of their heat pump demand into the nighttime as well as their EV. So that saved them almost £800 a year. Then working your way across, you see people making better use of their solar and making the most of those savings. Interestingly, when you get to the far right-hand side, you see the value to them, because they have a much lower energy bill, they're only seeing about £200 savings. And obviously, if you're putting a battery into those homes, that becomes a very unattractive payback period. But what was stark and very interesting from the findings was to see how the local flexibility revenue became a real normalizer. It really balanced out the benefits, because for the 2 households on the left that are using all of the capacity in their battery themselves, they have very little flexibility to offer back to the grid and be remunerated for it. But the homes on the right-hand side that have a lower energy usage, they actually still have headroom in their battery to provide the grid services to a much higher degree, and so can be proportionally paid better for it. So to step onto our main learnings from the trial then. Technically, yes, it was possible. We managed to get these systems in and up and running, and we had over 80% uptime even through a global pandemic. So really pleased with that. But we noticed that there are challenges around some of the rollouts, and trying to get to volume is the number one learning from this. How do we take a solution that is traditionally good for the able to pay or the innovators, and how do we get to the mass markets? That's the challenge we're taking forwards. Then economically, yes, there was good value for it. We managed to see less than 10-year paybacks for most of the households that had the systems. But where we could optimize for wholesale values, there was more value on the table. And so to move to the household part, how we can link the economic value that the energy retailers or those that are fronting the propositions to the proportional benefits that the household get is key to success, I believe, in seeing this volume scale up. And similarly, having better explanation or simpler explanation and simple control for the households was really valuable. In the trial, we set this up so they didn't have to change their behavior. They didn't have to interact with the system. It would just do it for them. But what we learned was there were times when people wanted to be able to switch it off when they went on holiday, even though the battery could make them money whilst they were on holiday. But there is that kind of learning that we all think we want things perfectly automated, but actually when you get into the system, you want to have a little bit of human control. One little anecdote on that, we saw that the solar optimization that was predicting how much charge to put in the battery overnight to leave enough room for the battery to charge up. When we improved the optimizer, actually the people in their homes didn't like it because they were worried that the battery hadn't charged up overnight enough. But when you fast forwarded it through the rest of the day, you saw the sun actually topped up that battery to the perfect amount so that it emptied just in time for the next low cost period. So the optimizer was working to the optimum, but because it was the optimum, the people got scared. So there's this fun learning that when you're in a intelligent home energy world, you still need to have some fuzzy edges where people can feel a little bit of security and safety. So yeah, thank you for listening and happy to take questions and do get in touch afterwards if you'd like to find out more. Sorry, final point just on those learnings. I think that what you saw in that product strategy that we're taking forward is from that kind of battery-centric view that works for a few thousand homes. How do we then move to rolling that out to the millions and unlocking the value for every household? Thanks.
Thank you, Tom. And thanks everyone for your presentations. I think they are really interesting projects and learnings from different markets. So moving on to the next section, it will be an open discussion. And I think a lot of you mentioned different propositions in terms of different complexity and different use cases based on different energy assets at home. One of the burning questions off the top of my head is that there's so many different solutions today in the market. Of course, GridX and Geo are leveraging multiple assets at home, but there are also solutions that are quite basic, playing around perhaps one node with several use cases. Which do you think the basic propositions or the more advanced propositions meet more the customer needs today, which could bring more benefits to the end users today? I don't know who want to start and to pick up this question.
That's fine. I can start and give my opinion. So, of course, the more advanced systems, we have to say, are more valuable, as I think Geo and GridX are providing more advanced systems or backing up more advanced systems. Maybe from an end customer point of view, there's monetary benefits and non-monetary benefits. And from my point of view, of course, those basic systems bring a lot of value already towards the non-monetary benefits like monitoring, participation, real-time views. But then the systems differ in degree of interoperability and differentiating features like program charging of EVs, for example. These are really important non-monetary values of the more advanced HEMS systems. And I think they're really not bringing the most value in terms of benefits, but bringing the most value in terms of differentiation from the competition. And therefore, they're really important in the end to have like an advanced system with all those differentiation features to be able to survive in this market, as we see a lot of different players from a lot of different industries moving towards this competitive markets. Maybe that's my view on the non-monetary benefits.
To provoke debate, then I'll jump in. I think I agree with Till that there is a lot of opportunity on the advanced side, and ultimately that's, I think, where the industry will tend towards. But I think the most important question for me is how do we get to volume fastest? And whilst you can optimize lots of different systems and lots of different assets, for an average household, that's really difficult to get your head around and to understand the need for it or what the benefits are to them. So I think for me and for us at GEA, the focus now is actually how do we do a basic system really well for millions of households and optimize the most valuable revenue stream to get that foothold and to get that starting position. That means that then the energy companies can have a large customer base that they can then develop into the advanced propositions. But yeah, so it depends on in terms of what's the best one. It depends on what your aim is, whether it's kind of thousands of homes doing everything or millions of homes doing something.
I think I have a sort of in-between position. I do agree that if we want to achieve mass markets, there is a need for like financial benefit for the end user, a commercial business case. And I think at the moment, the simple use cases is actually more able to provide that to the end user because it's less costly and it addresses most of the customer pain that exists at the moment. But I also think that we need to think a little bit ahead, and these solutions need to be future-proof, which means that this solution at some point will need to also support more advanced use cases around electricity systems, for instance. So the ideal solutions, I think, is to have something that is economically viable at the moment, but will be able to become an advanced system in the future when people will actually have more electrical loads in their homes and that the electricity system will be ready for demand-side response use cases.
Yes, I agree. And I like that you push like the future-proof systems because I totally agree with you, Tom, as well. It's important to have simple solution to start with. We're also trying to provide that with our flexible modular approach on the Xenon platform. But then if you're getting now thousands of customers, you want to stay with them or that you want them to stay with you. And from my point of view, as I said, like the competition will be really tough in the market. And so you need these more advanced systems to build the customer relationships with different features that really differentiate from the competition. That's why I'm saying, of course, or like that's why I'm agreeing to you both. But the view into the future is really important for us as like the long-term value is the most important value for most of the companies as they want to still exist in 10 years and still be the HEMS provider in 10 years. And that's why I really think basic systems are really important to be able to scale them now. But differentiation is in the end the most important value to be future-proof.
No, that's fair enough. And yeah, and we're taking the modular approach as well. So yeah, do agree.
Thank you, guys. I believe we can discuss this topic till the end of the day, but yeah, conscious about time. I move to my next question, and this question might be in the minds of many audiences today, is that when do you think the end customers will be more aware of HEMS solutions, and even when this market will become a mass market from your perspective? Anyone want to start?
Yeah, happy to take the lead if you want. I think it depends on whether we see different drivers, right, towards mass market. Is it going to be a regulatory thing that pushes it, or is it going to be a customer incentive that pushes it? And then I think probably one of the biggest trends is the EV adoption. But I think also across Europe and particularly in Germany, that difference in price between the grid, the cost of electricity, and then the cost of self-generation being significantly different, that actually the only way to find a cheap energy deal is to get a home energy management system and some solar on your roof. So I think in the UK, we're probably, this winter is going to wake a lot of people up to that need as well. That they can't find a cheap tariff by switching, then they'll look for other solutions. And it'll be interesting to see how many turn to solar PV and HEMS as their option.
Yeah, absolutely. I agree with you, Tom. I think there is a local aspect here. I think countries like Germany or the UK, we can expect HEM to become maybe not a mass market, but a significant market in the coming years. But there are other countries in Europe that will be much slower to take off, I would say.
Yeah, totally agree. In the end, it's the question of the regulatory answers that the governments will find. And I think it's also a definition of what a mass market is, as we see some companies already doing a rollout. For example, in Germany on the strong incentive to maximize the self-sufficiency. But yeah, still, of course, the topic is still being growing, and really interesting to follow that in the future.
Great. A lot of questions are coming up from our audiences today. So I'll pick up one or two to see whether we can cover, but we don't have the time to cover all of them. We will follow up with you by email after the webinar. So I'll start with the first question. Is each consumer optimized individually, or the system take cooperations between different consumers into account? Maybe one of the GridX or Jill can answer this question.
Yeah, happy to say for us in the trial that we showed, the homes were mainly optimized for them like individually, but we have the capability to optimize them as a whole set on one local substation as well. So you can do both.
Maybe just to answer for GridX, or from GridX perspective, of course, in the HEMS use case, it's possible to optimize the households themselves, but it really depends on the use case. So we're also looking at different use cases like energy communities or smart districts. And there we also have our module, cascaded energy management, where we take different optimization targets into account and also optimize on a district level or up to a district level. So all possible.
I'll just chip in with a short delta EE perspective. Both are possible, but what we're seeing at the moment is that there are very, very few examples of community using HEMS in Europe.
Yeah, I believe most of them are on trial stages. That will take more sophistication of systems to operate. But yeah, that would be our ultimate goal, to optimize the energy flows within the community and more households. Another question is that what are your takes on the local prosumer flexibility markets and the DSP flexibility requirements? I believe both companies you are having some services or use cases around flexibility. So what are your key takeaways on those markets?
I could start, Tom. That's fine. Of course, interesting markets and very valuable. Again, depending on the regulation in different countries, also on the technical requirements towards these markets. But yeah, of course, they add value to systems. To my point of view, the biggest value will still be provided by like more basic optimizations like self-sufficiency optimization, time of use tariff optimization, capacity tariff optimization. And then, of course, it's hard to estimate the value of flexibility markets. And as you don't know, like from pilots, how often in the year the flexibility will actually be used in the markets, or we only know by pilots, not in the mass market. And so definitely puts on top some value, and especially helps to differentiate again if you also can provide these services. Additional to the other optimization services, in very interesting markets.
For us briefly, in terms of the prosumer flexibility markets, personally, I think that needs to be fronted by another customer proposition. I don't think the mass market will go shopping for their own flexibility provider. So I think that needs to be wrapped into another customer service, most likely your energy retail tariff. So to that end, then onto the flexibility requirements, I think you need volume. It's the biggest challenge. And there needs to be some market reform in terms of the ability to have different assets providing flexibility at different times. So if all of the NPANs, the meters that are connected, can only respond to one flexibility signal, then I think it becomes uneconomic. But if you can choose which of your household portfolio responds in each different case, then it can start to become much more viable. But some changes on the metering so that the smart metering can deliver it. So rather than 1 second or sub 1 second, you can do 10-second metering to be sufficient. But some of those changes are happening, which is good.
Great. All right. Conscious about the time, we have a few more questions, but we haven't got the time to answer all of them. So we will follow up with you by email after this webinar. We're aiming to keep this webinar within 1 hour, so I will just wrap it up all here. If you have any questions that we have got time to answer, please feel free to also reach out to all of our specialists today. Otherwise, I'll just say thank you to everyone who comes today. Hope you enjoyed the webinar. See you and have a nice day.
Bye, everyone.
Bye, everyone.
Bye.